Hello friends, welcome to another practice question of linear equations. This is a word problem. We've done many word problems before. This is specially pertaining to speed, distance and time, and the concepts we'll use here are that speed is equal to distance upon time, time is equal to distance upon time is equal to distance upon speed, and distance is equal to speed into time. These are some of the concepts that we'll use in solving this question. So the question says a man travels 370 kilometers. So total distance, okay, total distance is equal to 370 kilometers. Partly by train and partly by car. If he covers 250 kilometers by train and the rest by car, it takes him 4 hours. This is condition 1. But if he travels 130 kilometers by train and the rest by car, he takes 18 minutes longer. Okay, so the sum of both of his journeys is done by two different speeds, and the total time is 4 hours in condition 1 and the total time is 4 hours 18 minutes in condition 2. So let's say if he covers 250 kilometers by train, okay, and let the speed of train is equal to t, and the speed of the car is equal to c. Now he covers 250 kilometers by train. So in the first condition he travels 250 kilometers by train and the remaining, that is 120 kilometers by car. In the second condition he travels 130 kilometer by train, and what remains is 370 minus 130 is 240. Okay, 240 by car, he takes 18 minutes longer. So if this is the distance traveled by train at the speed of train, then this 250 by t is the amount of time he spent in the train plus the amount of time he spent in the car is equal to 4, and this is our condition 1. Similarly, 130 upon t, that is distance traveled at the speed of train, gives you the time spent in the train, and 240 upon car gives you the time spent in the car is equal to 4 plus, it says 18 minutes longer, so I'll have to write 18 minutes as hours, so it becomes 18 upon 60. It is 6 threes and 6 tens, which becomes equal to 43 by 10. Okay, and this is my condition 2. I actually have to solve these two conditions. Okay, I'll repeat what I did here. I have to find the time spent in the train, that is distance traveled by time spent in the train is given here. Time is equal to distance upon speed. Distance is given 250 and the speed of the train we have assumed is t. Here the distance traveled in the car is 120 because 370 minus 250 is 120. And what I get here is 120 by c is equal to 4. I apply the same concept for the second condition. I get 130 by t plus 240 by c is equal to 4, plus because it took 18 minutes longer, I converted those 18 minutes into hours. Okay, so I have two conditions. Now the solution is very simple. I will treat 1 by t and 1 by c as my variables x and y and solve the linear equations. And what it will become is, I'm actually multiplying equation 1 by 2 for solving it, so that this value becomes 240, this value remains 240, and I can subtract the 2. So this will become equal to, I'll write the second equation first, which is 130 by t plus 240 by by c is equal to 43 upon 10. And equation 1, when I multiply it by 2, it becomes 500 by t plus 240 by c is equal to 8. Okay, and when I subtract this, what I get is a minus here, and a minus here. This gets cancelled, and what I'm left with is 130 minus 500. This whole thing divided by t is equal to 43 minus 80, and this whole thing divided by 10. Okay, now I have to solve this. So I'll take cross multiplication, and what I get is t is equal to 130 minus 500 is minus of 370 into 10 divided by minus of 22. Sorry, this is 32. Okay, and the minus minus gets cancelled, and what I'm left with is 2 5s are, 2 16s are, 2 8s are, 2 185s are. So I get 185 into 5 by 8. This is the speed of the train, and I have to plug the same speed in one of the equations to get the speed of the car. Okay, now do I want to simplify it any further? Will it give me any advantage? It doesn't look like it. So what I'll do is I'll try and solving for the car, and when I solve for car, what I get is